Greetings and welcome to our fourth video tutorial. Today we'll be looking at drawing 2D elevation sketches. Now, the place where you're going to want to start is, hopefully, if you followed the previous lesson, you'll have your own dimension limitations file, kind of like this one, with just an outline of what the envelope of the bridge looks like at different perspectives. Mostly we're going to be focusing on just the elevation view. So that's the overall design of the bridge, you might think of it. Now, you can follow the same method that I used in the previous lesson by assembling boxes along your bridge and basically just drawing inside those boxes, making sure they overlap enough so that your members can connect to each other, and more or less just parsing out some of the minor details. We're really just looking at the macroscopic view of the bridge for right now. So rather than kind of go through all the minute details and probably the boring procedural stuff of how do you put boxes together, I assume you can put boxes together and draw lines. I also assume you can draw lines. I'm just going to show you some of the finished results of a couple ideas I had on how you could use that idea of connecting boxes together and, drawing a very rough sketch of what the design looks like. What you might come up with. And here's the first example. It's probably an example you're quite familiar with, I should hope. It's basically just the design from this most recent year. Now you can see I've included the legs and then just, very single one-dimensional lines to represent each girder, each tendon, and each over-truss cord, pretty much. Now I have little green circles pretty much just to represent where connections might be. And also, you'll notice I've colored the members just to further illustrate which ones are separate members, like these two are technically separate members, and that's also hopefully evident from the fact that I have this nice little green dot here at the connections. Now, the first thing that you'll notice, and I'll kind of get rid of some of these layers, oh, well, yes, I do want that off. Thank you very much. Just kind of to unhighlight a lot of these things, you can kind of see the overall layout just with boxes. And I drew this actually originally just with boxes. So I took, I think maybe the legs first, then did the girders, and then just kind of came through, maybe started from one side, pretty much depending on symmetry. So I only looked at the left half portion of the bridge. I'll zoom in here. And I started with maybe this member and this one, and just kind of said, oh, okay, well, for this design I want to have all my members branch out from these central connection points. And that's very useful, especially if you want to give it away with consolidating connections, which is allowed nowadays. Very nice thing to do, since it only takes one bolt to connect at least. Here's 4 members. That's very economical. So pretty much you can see I've supplied sufficient overlap so that I can kind of get a connection in here for all these members. Likewise, you can see I'm placing my green little circles here, and you could do this on a sort of, noodle-based method. I kind of like it that way, actually. I haven't done it this way, but that might be a good way to do it. Just kind of having these little green nodes that you can insert in the bridge that are located inside the overlaps between all the members that you're trying to connect. For example, here is a member. It has this box intersecting with this box, intersecting with this box. So if I were to say, oh, well, it's not going to do it because I don't have it highlighted, but here, I'll hatch this region. Oh dear. Oh, there it is. This region. And you can see that's pretty much the overlap, and including the inside of the circle between all those members. So anywhere in that region, you can place a connection. And likewise with some of these other regions. So right here, you can place a connection, and here, and so forth. So using your knowledge of how your members are overlapping, you can pretty much determine and push to the limit, essentially, the location of your boxes. Now, I kind of angled it like this just to kind of emulate the previous year's bridge, but you can do whatever you like and move things around. So using that concept of overlaps can be extremely useful if you're trying to come up with an innovative design. And I'll show you in the next example what a very complicated design might look like. I say complicated, it looks reasonably simple from the outset. However, we'll take a closer look at some of these. So I'm on my box layer. I'll kind of get rid of some of these, and then I'll show you kind of where to start with this. Now, first thing that you'll probably notice is I have my legs here as normal, but instead of going with full-on girders all the way across, I actually have boxes here and here and here and so forth, intersecting with the bridge. And I'm only using effectively 5 girders here. However, you can interpret these boxes here as laterals. So I'll go to the plan view just to illustrate what I mean. But you can see here are legs on the ends, and then one of these, this box, say, would be a lateral. It would join the legs, and it would also join to the girders here. And you can also see here's some extra connection points. These would basically need to connect up to your tendons and up to your overtruss. And so that's the basic concept, is interspersing your girders with basically laterals. So you're using the same number of laterals, etc. You're just consolidating your bolts here. And I don't know. It's an interesting idea. Unfortunately, it has a couple of drawbacks, but right now we're not really worried about that. We're just trying to hash out some really basic ideas for what it might look like. Now, I've also extended the concept to our overtruss, and here you can see I'm pretty much using just our overtruss cord to connect to both of these outer connections, as you can see kind of here. And this goes up. This will connect to our first tendon. This will connect to the outer connections here and here in order to join those on the outside. And then I'm actually using my tendon to act as an intermediary between these two top cords, just so effectively, you'll recall in this previous model I was using no less than 7 overtruss cords. Now in this model I'm only using 6, plus I'm using maybe on the order of, I don't know, 4 tendons pretty much. So greatly trying to reduce the total overall number of members, but as you can see the number of connections is going up quite quickly, as you can see from this plan view as well. So now let's dump in our highlighted members, and these are just sketched in members just for examples. So here I have all my red girders in red, and I have all my laterals in yellow, and you can kind of see that in the plan view too. And these are pretty much all 3 girders, and they're connected on the outsides by these teal tendons. And here's what I mean as the implementation of this intermediary kind of connection between our first overtruss cord and our second overtruss cord. They meet at this junction, and this is actually something that Berkeley had done in their design. So if you're wondering, that looks kind of funky, well, Berkeley did it. It can be done. You could even fit maybe tube and tubes in here if you fudge the dimensions a little bit. Now notice I'm only changing angles of the top cords at basically junctions where I have my tendons. You could have kinks occur, or junction, where you have changes in angle in the overtruss occur at this point as well, and effectively have completely straight singular members. But you don't want to do that, just because as soon as you start doing that, you're going to be cranking in a whole bunch of moment right at that point. However, doing something like this, and again, something like this is precisely what Berkeley had did also with their most recent design. And I'll get into that a little bit more in the next example, but pretty much something like this. It seems totally wonky, I agree, it's a little bit out there, but there's some interesting ideas, hopefully, that you'll be able to take away from just kind of taking a look at this. Now, moving on to our next example. This is kind of a repeat, a more symmetrized version of Berkeley's design. So again, I've decided to take the liberty of just making full 6 girders across the bottom, so I don't have to deal with that jazz that I was doing where I was interspersing laterals. That kind of messes things up. So I just decided I just want girders all the way across. And I did something similar though with my cord design. So I did have this intermediary here, and I did have this angle here, so I'm only using basically 6 members, 6 top cords, to go over the full span length of the bridge. So again, you can see this tendon is acting as an intermediary between these 2 cords. I have my angle here at this point, and basically I'm using virtually the same node points, quote unquote, that you might think of as this most recent design, or this previous one, here, 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 and here, 4 node points, but I'm basically connecting them with tendons in a slightly different fashion, and also the deal with the girders is slightly different too. So using the same concept, and this is pretty much more or less what Berkeley had done, only using 6 top chords, getting away with basically 4 bays. Bays, as a terminology, essentially a bay is one of these kind of triangular regions, and yeah, more or less I'm connecting members here, consolidating bolts, hopefully not here and here though, so I'm losing out a little bit there. But all in all, this is a potentially feasible design. Note that I'm only connecting to the the girders here at 3 points, whereas here I'm connecting at 4 points. And this is also slightly deeper than this. This is slightly more shallow. However, notice in all these cases, I'm using the, okay, don't look at this. The one case that I don't follow that rule, but that's usually fixed. So notice in most of these cases, I'm pretty much using that overlap rule. So anywhere where I have boxes that are overlapping each other, I'm putting connections there and going through and doing that overlap thing. So using your overlaps to inform your decision of where you place connections, how you're going to connect your members together, and if you can do jazz like this, where you're doing these intermediaries between members, I think that's pretty cool. Hopefully you can give it a shot. I probably went a little bit over long, but I think there were some really good examples here, and hopefully they give you some ideas. So maybe, I would encourage you to continue playing with boxes and continue to pursue just, sketching out ideas, because that's really where most of the magic happens. Once you start getting into the procedural stuff, it's just kind of clicking your mouse along, and it just gets really tedious. This is the fun stuff, if you ask me. Anyways, so hopefully this was informative. I'll hopefully get a new lesson soon. I apologize for the delay on this lesson, but yeah, good luck and have fun.